Hello, everybody. My name is Valentin, and I will present here a bit of an overview about the basic dynamics and the geological history of the Afar Depression and the Danakil Depression. And this work is mainly part of my PhD thesis. So before we start, I just want to clarify some words because not all of you might be familiar to the region. When we are here in Addis Ababa on this map, and when we talk about the Afar Depression or the Afar Triangle, that's this area here, that is at lower elevation than the plateaus in the south and in the west. And the Danakil Depression is the northern part of the Afar Depression, and that's where we want to do our drilling. And then when I mention the Afar region, then I mean the whole region, basically the whole map, and that's the Afar region with a small r. Not to be confused with the Afar region with a capital R, which is the administrative entity of Ethiopia. But when we discuss big processes, I often use the term Afar region is the whole region, part of the Gulf of Aden and the Southern Red Sea. If we now zoom out a bit, that's a map of the whole region. The Afar region is here, and it forms a triple junction between the Red Sea Rift, the Gulf of Aden Rift, and the East African Rift system. Yes, but you will see in this presentation, it's a bit more complex than this. It experienced extensions since the Oligocene. Yes, but again, you will see that it's a bit more complex than this. And it's a textbook example of a rift, so you find this example in a lot of book for students and so on. And again, yes, it's a textbook example, but it's a bit more complex than this, and we're going to discuss this also in this presentation. The whole region experienced the eruption of the Ethiopian large igneous province approximately 30 million years ago that is linked to the Afar hotspot and rooted in the African superplume at the core mantle boundary here. And that led to the deposition or the emplacement of a lot of volcanic material all around the region. And this, I won't discuss and say a yes, but because I'm not an expert in this. But the three first points here, the triple junction, the extension, the history, and the significance, they are gonna be the structure of my presentation. So we'll first discuss the current tectonic architecture, then the geological history, and then the significance. The methods used for this study, it's mainly mapping. So you might have seen that the map, the big map is on the poster session. We have also done a map a bit zoom out with a bit of the Gulf of Aden and the Red Sea. And these two maps, they are available on Zenodo. That's a data repository. So you have the maps in all formats that you can imagine, and you have all the shape files, everything, all the data is available in open access. So you can all use this if you want for your research. We've done also literature review, tectonic plate modeling, and this and the discussion that I'm having now with you, it's been published a few weeks ago in Earth Science Reviews, and it's also in open access, so you can all access it if you want. Okay, let's now jump to the first part about the current tectonic architecture of the Afar region, and that will answer the question, we have a triple junction, yes, but. And to do this, we'll look at this map. I plotted here the earthquake in the region, but we also looked at INSAR, at GPS data, and so on. And we could highlight the areas where most of the strain is currently accommodated. And I insist on currently, because if you look at the situation 100 years ago, it was not exactly at the same place. And if you look further back, it changed all the time. But nowadays, that seems to be the area where we have most of the extension that is accommodated. If you now want to draw a plate tectonic limit, plate boundaries, that's difficult. For these areas here, it's quite okay, but here in between, it's not clear. So I didn't want to put a straight line, so I put a diffuse plate boundary here and here. And what you can see straight away is that it's not just three plates, the Nubian plate, the Somalian plate, and the Arabian plate, but there is also a macroplate in between, which is called the Arata microplate. And in the literature, it has often been called that that's the Gulf of Aden Rift, that's the northern main Ethiopian Rift, and this is the Red Sea Rift. But we think that if we consider the Arata microplate as a separate entity, we should give another name to this one, because the red series will not be called to represent the boundary between the Nubian and the Arata and the Arabian plate. So we propose to change this name and to call it the Afar Rift. And we think it would be useful for communication also among scientists. And you see there are other reasons also for this. So is it a triple junction? Yes, at large scale. If you look at this map that we've seen before, it's a triple junction with 3 main plates. But if you look at more details, it's a bit more complex with microplate, and the kinematic is a bit more complex. If we look at the GPS velocities, you can see that these are velocities relative to the Nubian plate, so this plate, and you can see that there's this counterclockwise rotation of the Arata microplate and the whole Danakil block. The Danakil block is this part here, and this rotation have important implication for rift propagation. If we have this counterclockwise rotation, I've made this very, very simple wood model to just illustrate the propagation of the rift. And it shows that the Afar rift propagates northward, and the Red Sea rift is propagating northward. And that's another reason to give them other names, because they are not propagating in the same direction. And that goes in contradiction with a lot of the literature published since the late 90s, where a lot of authors have drawn arrows towards the south. And even this year, there have been papers, at least one paper published with these arrows towards the south. But we think that it's not correct, that the propagation is going towards the north. And probably that might come from the confusion of the name, the Red Sea Rift, because the Red Sea Rift is propagating southward, yes, but the Red Sea Rift offshore, and not this Red Sea Rift. So that's another reason for it. To have a useful use of the Afar Rift name. So our conclusion is that it's propagating northward in the Afar. And I now want to discuss what are the implications for the Danakil depression, in which we are more interested. First, it means that we have more extension in the south than in the north. The extension rate is also higher in the south than in the north, and the timing is also a bit different. It means that to get to there's a pointer. Perfect. The timing is a bit different. The time at which you reach a certain amount of extension will be younger in the north than in the south. Okay, what are the take-home messages of this part? The structure is a bit complex with several rifts and rift segments. We have the presence of the Arata microplate, and the Afar rift is propagating northward. Okay, let's now go to the second part of this presentation about geological history of the region. And this comes back to the question, extension since the Oligocene. Yes, but it's a bit more complex than this. And to do this, we have reviewed the literature, and we've tried to compile everything in the region, what happens when, everywhere. So we have looked at tectonic, magmatic, and sedimentary events throughout the region. It's part of the paper I presented to you. Don't read the whole text, it's too long, it's boring, but it's all in this figure that you cannot read here. But we try to represent graphically all the events. And what you can see already on this graph is that it's strongly diachromous. So things are not happening at the same time everywhere in the Afar depression. So we'll go now through this history, and I will mainly focus on the Danakil depression because we are more interested in this one. And before rifting, the region was influenced by the Neoproterozoic East African orogeny that led to very strong lithospheric heterogeneity and weakness zones. We also have, during the Paleozoic and the Mesozoic, we have had several rifting events, for example, that formed the Mekele Basin, for example, and this led to many faults and lineaments that were again used during the current rifting event. At approximately 30 million years, we have the eruption of the flood basalts, but at this point, we don't have extension in the Afar region or the Danakil region. The only extension is in the Gulf of Aden at that time point. Between 30 and 19 million years, we have extension in the Gulf of Aden, in the Red Sea, and in southern Afar. But in Danakil Depression, we don't have any significant tectonic activity. We might have a bit of faulting, but more related to the nearby extension of the Red Sea Rift, but it does not form a basin per se. Between 19 and 30 million years, this continues. We have still extension in Gulf of Aden, southern Afar, Red Sea. We start to have oceanic spreading in the Gulf of Aden, and again, the Danakil Depression does not experience significant geology at that point. Between 30 and 8 million years, that's the most important period and the most important changes in the geodynamic of the whole area. We have the start of the oceanic spreading in the Red Sea, and we stop extension in the southern Red Sea. That's the point where in the Bab el-Mandeb area, we stop having extension, and that's the moment where we start rotating this Danakil block. That's the point where the wood model starts, and so that's the point where we start having extension in the Danakil Depression. So that's a major rift jump from the Red Sea to the Afar, and that's where we start forming our basin. At the same time, we also have the initiation of the northern main Ethiopian rift. So that's the moment when the region becomes a triple junction, because that isolates the Somalian plate that is now a different plate than the Nubian plate. Between 8 and 5 million years, we have the beginning of the sedimentation in the Danakil Basin, and that's the age where we have the oldest dated sediments in our basin. They are between 8 and 5 million years. And then I will go a bit faster because then there's a lot of things happening in the south, but I don't go into much details. 2.5 million year, 1.1, and between 1.1 and 0 million year, that's when we have the marine incursion that Anlin is going to talk about later on. That's also the time where we develop the Ertale range here, the volcanic range, which a lot of people among you study, and Emma can tell you more about this if you're interested. So that's the last phase. Okay, what are the take-home messages for this geological history? You've seen that both tectonic, magmatic, and sedimentary history is complex, it's diachronous, and is spatially heterogeneous. And one important point, I think, is that the rifting in Danakil Depression only starts in the late Miocene, so it's much younger than rifting in the rest of the Afar. Okay, the last part is about the significance of the Afar region, and that comes with this question. Yeah, it's a textbook example of a rift. Yes, but during our review work, we identified two different domains with different structure and geological history, namely the central Afar domain here and the Danakil domain. And you can already see all this yellow to red color are magmatic material. You can see already that there's a big difference between the central Afar domain and the Danakil domain. And there's another interesting point, and that's something that since the start of my PhD, I was wondering, then how is it so? If you look at this region here, the central Afar region, is the only region of the whole Gulf of Aden, southern and middle Red Sea, where you don't have a true oceanic crust, despite having 250 kilometers of extension. Why don't we have oceanic spreading in this area? And for example, if you compare with this area of the Red Sea, you have the same extension, but you have almost 200 kilometers of oceanic crust. So why is it so? There must be something different. And then we look at Mohodep, the crustal thickness. And when we look at it in central Afar region, it's not that thin. It's maybe something like 25 kilometers, 23 kilometers thick. So it's not too thin for having experienced more than 200 kilometers of extension. And if you compare this with the Danakil Depression here, which experienced something like 60 kilometers, there we have Mohodep of 16, 14 kilometers. So it's much thinner in the Danakil Depression, while it experienced much less extension. And at the start of my PhD, I was like, I don't understand it. That's not logical. Why is there no oceanic crust? Why is it so thick? And we explained this with a difference in the way extension is accommodated. And we could do some very rough calculation, and we could show that the extension in central Afar is accommodated by 20 to 50% by magma. by a magmatic addition to the crust that's called magma accommodated extension. And with this comes magma compensated thinning. So if you mechanically you do extension, you thin the crust, but you add so much magmatic material that the crust never really thins. In this, we see the strong influence of the Afar hotspot. And for us, this does not represent the conventional evolution of a rifted margin, of a magma-rich margin, but is more an analog for the early stage of development of an oceanic plateau. So if extension, we think that if extension would continue in Central Afar region, it would much more look like the Greenland, Iceland, Faroe Ridge than the normal magma-rich margin. In contrary, the Danakil Depression experienced less magmatic addition throughout its history, is much more typical of a magma-rich margin with a central volcanic range with seawall dipping reflectors, and that's also a good sign for our drilling because then it's representative of much more of the margin that we have worldwide than this very special exception of the Central Afar domain. Take-home message are that the Afar region is not a typical rift system. We see the strong influence of the Afar hotspots, but the Danakil Depression is more like a classical magma-rich margin. The last part, the conclusion and some outlooks and some thoughts. I think you've understood that the keyword of my presentation is complex. The tectonic structure, the geological history, the significance of the Afar region, they are complex. And detailed studies in the region should not forget the big picture. We should always keep in mind this big picture, this big history, and the complexity of it when we do our detailed study. And detailed study should not forget the influence of other fields of geosciences, in particular in this region. And I've done this figure for my PhD thesis, trying to show how all different fields of geosciences are connected and how they all influence each other with feedback mechanism. And we can not only study sedimentation in the Danakil Basin without looking at sea level, climate, biosphere, mantle processes, igneous processes, fluid circulation, tectonics, and so on. So I think it's one of the places on Earth where we have to look to be multidisciplinary and look at all different fields to understand our own specialty. And despite and maybe thanks to this complexity, I think that the Danakil Depression is a wonderful case study that can help understand many different scientific questions from many different scientific domains for questions that we have about our planet and even sometimes beyond. Thank you for your